Hi, this is AP Chem Free Response question number 1 from year 2006 by Natalie Reedon and Kelsey Roden. 1. Answer the following questions that relate to solubility of salts of leads and barium. A saturated solution is prepared by adding excess PbI2 to distilled water to form 1.0 liters of solution at 25 degrees Celsius. The concentration of Pb2 plus in the saturated solution is found to be 1.3 times 10 to the negative third molarity. The chemical equation for the dissolution of PbI2 in the water is shown below. First, write the equilibrium constant expression for the equation. That's Ksp equals Pb2 plus concentration times I minus its concentration squared. That's because you only put the aqueous ions into the Ksp expression, and since I minus has a coefficient of 2, then I minus is squared.
A2. Calculate the molar concentration of I minus in the solution. So for this you use an ice calculation. And so you have the expression PbI2 goes to Pb2 plus 2 I minus. And so initially you have 0, and then you have plus x and plus 2x because of the coefficient of 2 for the I minus. And then it's given that your final Pb2 plus concentration is 1.3 times 10 to the negative 3 molar. So I minus, which is 2x, is 2 times 1.3 times 10 to the negative third. So it's 2.6 times 10 to the negative third molar.
A3. Calculate the value of the equilibrium constant, Ksp. So Ksp equals the molarity of Pb2 plus times I minus squared, which equals 1.3 times 10 to the negative third times 2.6 times 10 to the negative third squared, which is 8.8 times 10 to the negative ninth. And we do that, we already have found the Ksp expression in part AI, or A1, and then we found the numbers for the concentrations of Pb2 plus and I minus in part A2.
B. A saturated solution is prepared by adding PbI2 to distilled water to form 2 liters of solution at 25 degrees Celsius. What are the molar concentrations of Pb2 plus and I minus in the solution? Justify your answer. So the molar concentrations of Pb2 plus and I minus are the same because the concentrations depend on Ksp, the equilibrium constant, and the equilibrium constant depends on temperature and is independent of volume. So even though you have a different amount of solution, the molarities are still the same.
Solid NaI is added to a saturated solution of PbI2 at 25 degrees Celsius. Assuming that the volume of the solution does not change, does the molar concentration of Pb2 plus in the solution increase, decrease, or remain the same? Justify your answer. As PbI2 goes to Pb2 plus and plus 2 I minus, the concentration of Pb2 plus will decrease according to Le Chatelier's principle. The NaI solid will dissolve, increasing the concentration of I minus. More I minus then combined with Pb2 plus to precipitate PbI2, so that the ion product Pb2 plus times I minus squared will once again attain the value of 8.8 times 10 to the negative 9 at 25 degrees Celsius.
D. The value of Ksp for the salt barium chromate is 1.2 times 10 to the negative 10th. When a 500 milliliter sample of 8.2 times 10 to the negative 6 molar barium nitrate is added to 500 milliliter sample of 8.2 times 10 to the negative 6 molar. 1. Assuming that volumes are additive, calculate the molar concentrations of Ba2 plus and CrO4 minus in the 1 liter of solution. So the new volume is the 500 milliliters plus 500 milliliters is 1 liter, and you use the equation M1V1 equals M2V2 since no precipitate is observed, making it a dilution problem. So for Ba2 plus, it would be 8.2 times 10 to the negative 6 molar times 0.5 liters equals M2 times 1 liter. And for CrO42 minus, it would also be 8.2 times 10 to the negative 6 molar times 0.5 liters equals M2 times 1 liter. So the concentrations of Ba2 plus and CrO42 minus are the same, and they're equal to 4.1 times 10 to the negative 6 molar.
Use the molar concentrations of Ba2 plus ions and chromate 2 minus ions as determined above to show why a precipitate does not form. You must include a calculation as part of your answer. The product Q equals the concentration of Ba2 plus times the concentration of chromate 2 minus. This is the same as if it was a KSP expression. So, since we found these values in Part 1, you would do 4.1 times 10 to the negative 6 times 4.1 times 10 to the negative 6. And that equals 1.7 times 10 to the negative 11th. And since Q is less than KSP, no precipitate will form. You only have a precipitate form if K is less than Q.
Thank you for watching. All answers were verified by apscore.org.